Okay, well, thanks for the introduction. So what we're going to talk about is continuous integration and how it's essential for a DevOps, and we'll kind of go through what us at OSI have been doing for, I'd say, probably the last 2 years. But the last year, what we're specifically talking about is Kubernetes-based deployments in this presentation, and how we've really kind of moved forward with doing that on a regular basis for most of our projects at this point in time. So, Jevin. So, like I said, I'm co-presenting here with myself and Jevin. So I'm the manager of the group. What my group manages is what are called Enterprise Managed Services, and that contains our Enterprise Assurance Program, which is basically help desk support for our clients, and then the infrastructure that we manage for our clients, and the DevOps behind that, cybersecurity, the cloud environments that they're running in, on-prem networks, and so forth. I've been at OSI for about 1.5 years. And my background is actually in geographic information systems. I come out of the University of Buffalo, bachelor's, and then a master's in GIS from Penn State. For this, I worked for a civil engineering firm doing a cloud migration for a few years. A bulk of my time was spent at the Department of Energy, running their cloud program and GIS programs. Before that, I was a developer at Esri, a GIS software company. Jevin, why don't you talk about yourself?
Yeah, so I recently graduated from NEU in 2020, and currently at OSI, I'm working as an infrastructure specialist. I manage kind of like the newer technologies here, some of them involving Kubernetes, AWS, Azure, DigitalOcean cloud platforms. I often work on a lot of the CI/CD enhancements, and also on the infrastructure side with a lot of the servers.
Okay, so what are we going to talk about today? First, I want to go through some terminology that we're going to be throwing around in the presentation. So just kind of a high level things to expect for some words we might be using. We'll talk about CI/CD, the Jenkins process and how we use Jenkins specifically in our Kubernetes deployments. The branch and workflow that we follow within GitHub, the release process that we follow for a Kubernetes deployment. We'll talk about Kubernetes a little bit. This is not a Kubernetes discussion, but we're going to show how we implement Kubernetes into this process, how we go about releases, and then finally, Jevin's going to walk through a very quick demo of the CI/CD process. So going to the terms, one of the main ones is an image. What is an image and how we use it? I mean, we refer to it as a Docker image. It's basically like a blueprint for how to build a code repo here. We have our Docker containers, which are built off of the images that are necessary to then launch into Kubernetes environments, and how that's all getting deployed into some sort of registry, which is the next one. So we utilize primarily the AWS and Azure registries on a regular basis, and that's where everything is hosted. Kubernetes, and basically how we deploy into a Kubernetes environment, which takes the containers and launches them into pods, and we'll go into that and puts them into nodes. So we'll get into that, some of that detail. And then Jenkins, which is the open source CI tool that we use here at OSI. So continuous integration is basically the process of getting code and running through different checks to verify the quality of the code and to automate the deployment into a container registry and eventually into our clusters in Kubernetes. So we automate that process up into the dev, what we're going to say the dev namespace, and that's the delivery portion. So the continuous delivery gets it from once you have that merge request and going through into the master branch and getting that all the way to onto a dev environment. Jenkins is our open source automation server that we use to support the CI/CD process. There obviously are many different CI/CD tools. We come across them all the time. Jenkins is our preferred option for that. And how do we use Jenkins? Every pull request, Jenkins creates a trigger and builds and tests and runs against the code. So Jevon's going to go through in detail the tests that we're running against the code that's then pushed in on every pull request. And then once that is pushed into master, Jenkins then goes and tests, builds, and deploys a Docker image that pushes it up to the container registry, and then eventually pushes it into the dev namespace in the Kubernetes cluster. We primarily are doing this inside of AWS and Azure using the Kubernetes service and container registry service that they natively offer. We also do this in OpenShift on DigitalOcean. But primarily these days, we've moved forward more on an AWS and Azure environment and using a lot of their native managed services they provide. Yeah, Jevon?
So here are some of the Jenkins tests that we do. Some of them align pretty closely with the OCA as well. The code styling, the formatting, we're using Black for that. The image building, we're using Docker. The unit tests, we're using the test enabled, and also we also test for the Kubernetes deployment. And we'll get feedback if any one of these tests fail. So this is kind of like our GitHub branch structure on how we have this. We use a master branch and also a future branch, where the master branch is always updating the latest code, and the future branches can be branched off of that for any of the developers. So this is kind of how the Jenkins test job looks. Essentially on GitHub, we have a pull request webhook that hooks over to Jenkins, and from there it tests against the code this way. Here we have another job set out that is, there's a webhook linked over to master, and the master branch will essentially build the Docker image, push it up to the registry. Some of them we have in ECR, in AWS, and some of them we have in Azure, and we also have registries in GitHub Enterprise. But from there, it'll go ahead and try to build the image and then deploy it over to the Kubernetes development namespace. And lastly, we have another job that's a Jenkins release job. So once it's in that dev namespace, we have a manual trigger that we can do on the Jenkins release job where we can have it create the GitHub tag, create the registry tag, and also deploy it to a test and QA environment. And this is currently in like a beta stage. Ben, I think you're muted at the moment.
Sorry. So some Kubernetes definitions that we have in place here that are standard Kubernetes terms, but just to kind of go through them again. A pod is essentially a component of Kubernetes that can hold one or more containers. Next slide. The namespace is how we organize the subclusters. So within a namespace, so inside the cluster, we can have multiple namespaces. We run our dev, test, QA, production. We can run other applications inside of a Kubernetes cluster. So the namespace is a way to organize your cluster within your cluster. A node is essentially an instance, a server, VM, whatever you want to refer to it as, that runs the pods. So in AWS and Azure, we set up auto scaling groups inside the cluster. So we can run on 1 to 2 nodes until it needs to scale up, and then start building more nodes and then deploying more pods. So there's no persistent storage on these things. It's essentially running these pods and auto scaling based on the resources necessary to run things appropriately. And then the load balancer, so we have our ingress that comes in and basically distributes the traffic around the nodes. And that's essential to basically, in the end, access your application and get through the cluster securely. So the first is our dev namespace. So this is the one that is automatically deployed to on every change to the master branch. So once it gets into Jenkins and we push to the master, it then automatically pushes to the ECR and pushes it down into the dev namespace to have a new dev environment available. And then for our test namespace, so the dev namespace is done automatically by our developers when they actually go ahead and merge through. The test right now, our infrastructure team would deploy to test. We're actually working on automating that process, so it would automatically get deployed into the test namespace. Same thing in QA. When it's ready to go to QA, we run the Jenkins release job and we deploy to the QA environment. That is a manual step at this point in time, and will probably remain that way for the time being. And then our production environment. So once we're ready to do a production release, we would again run the Jenkins release job, back up the environments, and deploy to production. So it basically pulls the latest production DB and file store, pushes it on to the other spaces, and then we would then deploy everything to production. So just kind of an overview of the breakdown here is at the bottom level, we have the dev namespace. And the way we run things is we can run the database and the file store in pods, or we can use the RDS and we can use S3. So for the dev namespace, everything is local to the pod. We're not nothing is persistent. So next one. The test namespace and the QA namespace, it pulls down the backup. It runs a backup cron job and puts onto the test. It puts the database and the file store. On QA, it does the restore, but it actually hosts it inside of the RDS versus being locally to the pod. And at the top level, we have our production environment where we have a managed database in AWS at the RDS, or if it's it can be Aurora in AWS, it can be Postgres, same thing in Azure or DigitalOcean. And then the file store would run on blob storage or S3 storage inside of the cloud environment that we are on. And daily it runs a cron job and backs up everything and puts it into a backup directory inside of S3 or blob storage. So now we're going to just quickly go through a demo where we're going to merge a commit, run through Jenkins, have an image built, and then have an updated dev namespace. So this is where Jevin's going to do a quick walkthrough.
Let me share a different screen. Okay, can you see my GitHub screen at the moment?
Yep, you're good.
Okay, so here I created a PR. This is our master branch. This is our feature branch. I'm going to be merging it in, and we're going to be able to see the automatic actions that happen. So here I merged the branch through. I'm going to delete that. And over here, I'm going to see a build being triggered. And we can kind of watch through that build. So here there's a trigger. It's going through, getting the repo. You can see that it's now building the image. Now it's going through the step where it's pushing the image up to the ECR. And now at the end of it is where it triggers, this portion is where it triggers the actual deployment over to that Kubernetes namespace. So if we go over to this website, we can see that the website is currently down because the container is still rebuilding. And it may take a little bit for it to come up as well.
So while we wait for that to come up, we can move on to questions.
Yep, Jevin. So any attendees have some question, could post in the chat or could directly ask over here.
I'm sorry, what was the question?
I think we're asking people to put the questions in the chat.
Oh, okay. And here we can see that the container is finally up, or sorry, the pod is finally up. And we can see the Odoo maintenance screen.
So Jevin, there's a question, I think, do you have some advice about how to put module updates in production without interrupting service for the customer? I don't believe we do module updates without planning a production release and planning for outage time with the client.
So I think that you might be able to do it with the load balancers, but yeah, we haven't tested with that yet. Shifting the application over to a different load balancer and then updating the second one and then moving it back.
Hey, Ben, one question on the testing. Ben?
Yes.
One question on the testing. You mentioned that you're using Black for the testing of the application, right?
Mm-hmm.
Yeah.
Is that kind of code testing? Is that high level application testing? What kind of testing is that?
It's a formatting tool that we use to make sure that the Python code all aligns together.
All right, so but it's really not about the application testing itself. Like if there's any kind of bug in the application, you would not find out. You just find out about the code quality itself, right?
Yes, I believe. Yeah, I think for us, I'm not too sure if it does anything else, but we use it for just formatting the code.
Okay, good. Thanks.
And so right now, the tool that's actually building this is the Marabunta tool. We use it for our migrations. But that kind of concludes the demo on how we can push to the master branch or have the developers push to the master branch, and it'll automatically trigger Jenkins, and Jenkins will go through and try to build the image. And if at any point it fails, we'll see that the job failed, and the developer will be able to come here and see that their build failed and kind of figure out how that failed and what they can do to fix it. And if it goes all the way through, then it'll end up deploying, and then they can actually view the changes that they made on that dev server. And from there, once they're good and they're happy with what's there, we can then go and push it to tests. And that's where we have those cron jobs running automatically, pushing the production backups and over to the test and QA system. And we can see what the Marabunta tool does there as well with building with actual data.
Sounds good. So Ben and Jevin, I think we have like few more minutes. So maybe we could wait for if there any question.
Okay, we'll hang around.
Yep, sounds good.
Got one more question. If you have those kind of developments done on separate Docker containers or Docker images, I understood. How do you assemble those if you want to migrate the whole machine to some other version or something?
Can you repeat the question?
I was wondering, I think the developments are dependent on the branches, right? And therefore you've got different Docker containers for all of those kind of developments, right? So each branch is a Docker container itself. Is that true?
No. So
Hey, Jevin, sorry to interrupt, but I think there's some echo from your side.
Okay.
Hang on, I'm muting myself.
Oops, sorry. So the master branch is the one that ends up building the Docker image and ends up updating like a latest image. The feature branches, those don't really do anything until they're merged into that master branch. And so if the developer wants to build a Docker image locally, they can. The repo is set up to do that. But the actual merge into the master is what will trigger that image build and push over to the ECR.
Joe, we got some customers with building a namespace for each of the pull requests before it gets merged. That's something that can be done and automated. The issue is it consumes a lot more resources. We actually had one customer with what we show today runs in the same cluster. What we've done with this other customer is they had 3 different clusters for the 3 different stages of development. And so one of the cluster was dedicated to running all the container and building the container for all the feature branches in the pull request, but it's not the same budget.
Well, thanks, Max. It's somewhat related because we're wondering if it's possible to really then reconcile the coding that had been put out into separate Docker containers into one. That was what I was looking for.
Anything else?
Ben, I think that's it. I guess then. No more questions I could see in a YouTube channel or over here.
Okay, well, thanks for the time. Enjoy the rest of the day.